Let's take a look at this problem that we discussed a little bit last class, where we want to convert this phenyl bromide derivative over to this tertiary alcohol. And you can see that we have a hydroxyl group here in the molecule, and that's going to be a problem when we want to do Grignard chemistry. OH groups, so OH groups are going to be not compatible. I'll just put not comp with Grignard reagents. Those two things are not going to be compatible. We're making a hydroxyl group in the end, but that comes from another piece that we're going to use. But this hydroxyl group is not going to be compatible with a Grignard reagent. So how do we circumvent this? And the way that we do this is we protect this hydroxyl group. So what are we going to do? The protecting group that we learned was to use trimethylsilyl chloride and triethylamine. So what we're going to get is we're going to get this, what we called a silyl ether. So we're going to have our protected silyl ether. So it's going to be O, and the abbreviation, or the acronym, was TMS. So this is our trimethylsilyl ether. This has a silicon-oxygen bond that we talked about, and I'm going to talk about that in a little bit, about how to break that oxygen-silicon bond to regenerate, or to go back to our hydroxyl. So essentially what we're doing is that we're covering up that hydroxyl group with this TMS group. So, what do we do? Oops, I'm missing my bromine here. So, I'll put the bromine in here. So, what do we do next? Now that we've covered up that hydroxyl group, so that it's not going to react when we form our Grignard reagent, we're going to treat that with magnesium metal, and you can use diethyl ether or THF, and then we're going to form our Grignard reagent. So, we're going to form our Grignard reagent. So, here, I'm just going to draw this up like this for room. And we're going to have our R. So MgBr. So this part of the molecule here, this is our R group. This whole thing is our R group. Remember when I was talking about RMgX? So this is our Mg here, and this is our X. X always denotes any kind of halogen. So we have our R and our MgX. So also, like I said in class the other day, this bond can be regarded as almost ionic. So we have a carbanion here, so basically we have two electrons that are going to be able to attack the carbonyl group of a ketone. So what's going to happen next? Let me just erase this so I have, so I have some more room to work. Here we go. So what's going to happen next is we're going to take our Grignard reagent with our protected alcohol, and we are going to react that with a ketone. And the ketone we're going to treat it with is this ketone here. So what's going to happen is that these electrons here are going to come down and they're going to attack that ketone. Okay? So that's going to be the first step. That's going to generate a tertiary alkoxide. So we know we need to throw in water as a proton source to protonate that. So that's going to give us, again, our silyl ether, OTMS. And now we're going to have our tertiary alcohol. So now our other hydroxyl group on the other side of the molecule, that's still protected. And I don't think I went over this in great detail during the last class, but the way to remove that is using tetrabutyl ammonium fluoride. If I was writing a test or a quiz, this is the reagent I would choose. I wouldn't choose dilute acid. TBAF is the most commonly, tetrabutyl ammonium fluoride is the most commonly used reagent for the deprotection of silyl ethers. So then we're going to end up with our deprotected alcohol, and we're going to have our tertiary alcohol over here. And that is our product. So you can see that the overall process, like we talked about last class, the overall process is to protect, do our chemistry that we have to do here. We do our Grignard chemistry. We use our Grignard reagent as a nucleophile, and then we deprotect in the last step. In the last step, we rip off the functionality on our primary alcohol here, and there we go. We were able to protect our alcohol, and that is how we generate the final product that we want here.